Arch in St. Louis.
Are you saying you're the Discovery Day?
Or the Parabolic.
We could. That's all I'm saying.
Alright, let's dive in because we need to talk about imaginary numbers today, which are not imaginary. But before we do that, we have been hired to solve a problem. This is real deal stuff. These are the situations that people encounter. So, my sister-in-law for a while, and now her roommate, is part of event planning. And event planning has a lot more that goes into it than people realize. Like, will things fit is a pretty important question. Yeah. Because if you're planning an event and the things for your event don't fit in the space for your event, it's not good. So, we're planning a concert. It's going to take place under the Gateway Arch. Hopefully not in the middle because that's water. But apparently, well, but it's like right beside the water. But so we're playing a concert.
But the middle of the Gateway Arch is
the road or something. Okay, yeah. At the top or you know, like up there.
No.
Can you
the
get
top
up there?
You can go up. Yeah, they have like a trolley.
They have an observation deck or window thing.
Yeah,
I've never been. I need to go. Never been to St. Louis. So.
Oh, if you do go, you should at least go and look at the city museum.
Okay, I will. So here's what we know. The concert stage is supposed to be set up 15 feet inside the base of the arch. So I know you guys, if I just say 15 feet from the base, you'll be like, oh, put it out here, you're fine. No, 15 feet inside the arch. They used a prop guitar that is 30 feet tall. We need to figure out if this 3-story tall guitar would fit. So the only thing we know is that this arch is really nice and symmetrical.
Yeah.
It's 630 feet wide. It's 630 feet tall. So if we help you out a tiny bit, and we say we're going to build a parabola that's going to model this arch, we should center the arch on the y-axis. So work with your groups, your teams, whatever you want to say. Try to figure out, is Gunnar just straight up not here today? Because we're like beyond start time. So.
He wasn't here.
All right, Gunnar, feel better. You're not going to watch the video, but if you watch the video, feel better. Yeah, try this out. You know a lot of information, actually.
Just get down to business, guys. I would not want to need to correct behavior today. Get to business doing what you're supposed to do.
We have the Y and 6 on. We could do it. We have the X and 5.
I don't understand this question.
Yeah, it is. Look at the bottom.
Now I'm bit to business, guys.
Thank you, sir.
I don't understand what the question is asking.
What is the equation that could model this parabola? Then we're going to input something to figure out that 15 feet from the base on the inside, how high is the arch? So we know that we know this point, and this point, and this point. And that should be enough.
I was stuck in my head yesterday at tennis. At tennis.
The tennis ball makes a parabola.
Tennis ball makes a parabola.
Are you talking now?
I'm sorry.
Yeah, tennis ball makes a parabola. And the parabola can be measured by negative.
No! It can be
Hey, I didn't sing it.
Negative b plus or minus the square root of b minus
It's getting very annoying.
Here you go. Minus the square root of b squared minus 4ac.
It needs to be stapled with the original test.
What could the vertex of this point, or what is the vertex based on how we put it on? Huh?
0, 630.
So when x is 0, so we could say, okay, if we're making a function f of 0 is 630. When we have an input of 0, we have 630. What are these points?
X intercept.
Negative 3, 15, 0, and positive 3, 15, 0. So we know the zeros, right? It's a difference of squares. We also know that by how we saw it. Since it's a difference of squares and we know that by how we're looking at it, we know there's not going to be a b term. Yeah, maybe? No? I don't know. Or at least is f of x. Maybe you don't know about equals 0. So what do we get there?
X squared minus 99,225.
99 what?
99,225.
225.
Yeah. I don't think that works.
Yeah, I don't think so either.
That's not gonna work. What are you talking about?
Now that would give us the right zeros though, right?
Yeah.
What's wrong with it?
It won't give us the y number then.
Okay.
That means the x is
So we know this, right?
Wait, so we need a coefficient for the x squared.
Work on your own. I might write things up here on the occasion, but for a moment I'm waiting. I'm going to let you guys play with this. Anyone know anything immediate about our coefficient that we're going to be working with?
Good, pretty big.
I think
Chris?
I realized something has to be a negative x squared.
It has to be negative because for our parabola to point down, it has to be negative x squared. As my x gets bigger, it brings my value down. Because when my x is nothing, my value is as high as it will ever be. My f of x, my y value. So the x has a negative effect on the output. Because the parabola is upside down.
Why
We see
is it
that
upside down?
this,
the
because
vertex
a
is
parabola opening up like this is said to be correct.
negative.
That is the x squared. Because when we just have the parent function, if we have y equals x squared, which is our parent function parabola, it goes like this. So this is technically upside down from the parent function. To do that, we know that we just put a negative in front of it. So our coefficient that we use is going to have to be negative. So, so if x is 0, play with this.
What? No.
It won't work.
What do you mean? It won't work?
Okay.
jam into that quadratic song. Do we all agree with this? And we're okay with x plus 315, x minus 315, we just use the zeros. And do we all agree with that? Okay. So then from there, what I wrote on the other page was for this to equal, 630, we would say it's f of 0, which means we need to modify something. And that might be easier. Come down here. And look at the fact that this quantity, if I group that, is like grouping on the outsides of this quantity.
Wait, so if we solved that and you got your x value.
What do you mean solved? Well, okay. We know the x value. Here, the x, well, that looks like a decimal point. But here, where the function is 630, x is 0. What we're trying to figure out is when I put in 15, what's my output? But the problem is we don't actually have the right equation right now because this isn't true.
It would be x.
So we're looking for this value. Is there anything else that we know or that I should change with what I have written up here to help me solve this? Ethan?
Well, we at least know it's negative.
Okay. What's this?
The 630.
Say it louder. Say it louder.
Yeah. She's a little bit shy. No, Jenny, shush. You are.
It's x, right? If we're saying f of 0 is 630, this is nothing, right? 0 squared is nothing. So right now, the equation that we have,
I'm going to say that's slightly off.
I'm going to say it's not.
Oh.
Wait, so
we're looking, no, actually no. That's not our a necessarily, depending on what happens. So I'm going to make this just something random right now. Sometimes it would be the a, but there are situations where those values would be different. So we're trying to figure out what multiplier makes this true. You already told me it's negative.
wild guess.
Looks like it.
Wait, I think this is my point.
Okay, well that's 0.006349263.
That's your coefficient.
Oh,
This value is the coefficient. When we write it as an equation, and when we plug it back in here or up here, and we look at what it does, when it distributes through, which is going to modify the x squared, as well as the c value. What were you going to say, Colin?
Oh, I was just going to say that I know what the fraction is for that one, which is easier to work with than the decimal point.
Yeah, the approximated. Oh, you know what? The reduced. What'd you reduce this to?
-1.5.
So decimal approximation 0.00635. And then your x minus 315, x plus 315.
No. Well, look at the upper makes me cringe.
Because the standard parabola, for it to have zeros that are 630 wide, it's huge. What we've done now is squish it down. Say we don't want the parabola to be as tall as that standard relationship x squared. We got to get it way shorter than that. What's up? No, but we have an extra because Gunner's not here.
Yes.
We're talking about the Great Arch in St. Louis. You knew that the coefficient for the parabola was, 635 10,000ths, right? Yeah, of course. 10, no, that's not even 10,000. That's like 10, 100,000, 100,000ths. 635 100,000ths would be our coefficient.
That's a small
Thousand.
number.
100,000. All right, ready to move on? We're not doing Mosio. We're moving on to lesson 6. Mosio, we're skipping. Sorry, I know your heart was so set on it. Negative plus or minus the square root of b squared.
What is suddenly break up breaks?
Oh, wait, we didn't solve the problem.
No, you
Yeah.
memorize it. Negative b plus
No,
n
hold up.
over
We didn't solve the problem.
Boy.
Let's remember, all we did was get the equation. Now we have to solve their question, right? So remember, if we want to do this easily, we can use technology to help us. If you had this in your calculator, you could just then plug in x. But if we know that our x is 15, we could solve it for, we could just plug it in and do the math, right? So 15 minus 315, right? Isn't it 15 feet away from the base? Yeah, so that's negative 300. This would be 330, because that's negative. And then this is, what it is, ugly as it is. 15 minus 300, 15 plus 300. Our input now is 15. So don't overthink it. Once you get the equation, it works just like any equation we have. We just plug in for the x. What is the action?
628.65.
We can't have a negative height.
How?
I got 58.5.
Oh, hey, this is negative.
Oh wait, no, it's positive.
I forgot to carry it. Oh, this is not the calculator. What do we get?
628.65.
No, wait. That doesn't make sense.
I got 58.5.
That makes a lot more sense.
I got the negative 0.
Do you guys have enough zeros?
2 zeros.
Yeah,
Let me
one at the
check.
beginning and 2 at the decimal.
Point
Did you
006.
figure out the square of those 300?
Well,
What? I think they forgot the square of the 300. Because that's what I think I got.
Okay, well, it depends on if you are looking at it in quadratic form or looking at it in the factored form. But let me check. I'll do the math
I
in
got
line.
6.
Point
Yeah,
zero
for
zero.
the square of the 300, I just got 628. Yeah, I have the square of the 300.
Why?
Because if you think about it, it's x squared. What?
Yeah, but
The equation is 0.00635 times x squared minus 99,000. Oh, I just plugged it into that.
Wait, I did the bottom. I did the bottom one and I still got the same thing.
What'd you get? Because I am having the same mathematical error if I just plug it in here.
Yeah, 628 squared. Okay.
Why? Might this be
When you're
X?
squaring with.
I just plugged it into like.
Wait,
I
because
you know.
I just did the like f of 15 equals.
squaring
If
15.
you do that, then it comes out as like 628.
So if we look at this
Imaginary numbers.
in the factored form, then, or sorry, not the factored form. I hate that.
Wait.
That used to work. So we know 620 is wrong, right? That can't be true.
Yeah, that we know.
This, we said, was x squared minus 99,225, right? Now we have a coefficient. Now wait, does our coefficient apply to only the x squared or both values? Both values, right? So it's still on the outside there? Yeah. Is it? Because then that would be negative 0.00635 x squared. I don't know what that multiplication comes out to be. I get 630 actually. Or no, this. This, when distributed, is giving me
Yeah, it's like 630.
630.08. If you want to be accurate.
Yeah, that's what I got.
Would that make sense in the realm of this parabola? Like this constant value? What does the constant do to a function? Moves it up and down.
Yeah.
Right, our y-intercept point, because when x is 0, this should be our y-intercept. So if we plug it into this form, let's see if this works. So we have to square the input value. Here it wasn't working right. We have to multiply before we do the arithmetic, because how the binomials are actually different than the trinomial that we get. So do not do this. Don't do it.
Wait, so
Figure out your quadratic, because well, your function, right? This could be, we could write it as a quadratic, then apply your coefficient and make it happen. And actually, we should be able to here do this and then multiply by that and still get the right value. So we do. Forget about the negatives because we know, we know it'll become positive. So you 0.00635 times, what is 15 squared? 225. I feel like I need to do the division again and check if we have enough zeros written here or something. And I'm not even using the graphing calculator, so I'm a little nervous about that too. I know exactly what we're doing.
what are we doing?
Figure it out. I know exactly what's wrong here.
Is it because we rounded it?
I know exactly what's wrong.
Is it something like simple or something not simple?
All right, you ready? Because I'm having one of those facepalm moments. So you ready for yours?
Yes.
What?
Is
Wait,
it
what did we do?
000?
No, it's not.
What did we mess up?
Well, it's about to show us.
Everything.
I know, but I have too many baseball moments.
Yeah,
You know,
the baseball
Jenny.
moment
I'm that type of person that tries to do something right and fails. Wait. Okay, we have that right.
Did we mix up the
We
zeros
have
and
that
the
right.
coordinates?
We have that right.
No, but that means that
I can't see the board.
It's 300. That's 300. 300.
We
Yeah.
were working working with 15.
With
We're
15, it
working
would be
with
like about
300.
628.
At 15 feet from the center,
So is
we're almost at the tip of the parabola. But at 15 feet from the base, our input is either negative 300 or positive 300. So this is why this fell apart. And I was sitting here thinking, like, why? Because this should work. Like, mathematically, if we follow the rules, this should work out as long as we pay attention to signs. But the problem is we plugged in 15 instead of 300. So if we try this again, let's verify if this will work or not. Wipe this all out. So the danger with whether or not you plug it in before you get to the quadratic or not comes from signs. So especially if you're using a calculator, again, I'm going to remind you your calculator is really stupid. When it squares a negative, it gives you a negative. So that's why we like really caution you. 300 minus 315, this is negative 15. 300 plus 315. 615? Sorry that my color changed.
Really right.
Right? Yes? Maybe if my x is 300. We're just trying to see will this work out.
Now we get the 58 thing.
Yeah, now we get it. So it fits, yay!
58 and a half feet approximately.
50 and a half.
So not 15.
300.
Now, that was one of those situations, right? Well, we're doing everything right. What the heck is going wrong? Very, very simple mistake.
Ours looks like this.
I'll even own that. I mean, that was not, there's nothing written out in the answer key about what we're plugging in, so I just, like, instinctually was like, oh, 15, plug in 15. Be careful to analyze what you're doing. On those state tests, especially error, park, whatever it's called now, if it seems like it can't be right, it probably isn't. Don't get yourself beat up like, oh, I don't know how to do it. Look for the simple errors first. All right? Let's just do that. All right, now let's flip to complex numbers.
Yay!
Wow.
I love
It's really not
complex
that bad.
numbers. They're super easy. They're like just algebra.
I bet they're not super easy.
They are. They're just algebra.
They're really not bad.
Okay.
They're just like I times I equals negative 1.
Jen, you made it sound like you're like,
I mean, she's
It's really
right.
not hard.
What she said is true.
no, but sometimes it's like, oh, it's simple. You just do the blah, 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 blah.
So I do know it's simple once you learn it.
All right, so back to discussing our parent function, right? When we look at the parent function, x squared, we say how many answers, or how many inputs can be squared to equal the value of 2. This is like what we did yesterday with the intercept on the calculator. Although if we just think about it, x squared, sorry, that should line up there. Imagine that it does. So I'm looking for output of 2, output of 2. We know that there's going to be 2. We then can algebraically work with it, change our function into f of x being x squared minus 2 to isolate the output value. Not looking for an output of 2, but looking for any output in that function. When we look for the zeros, that solves it, and all that really does, shift your parabola down. This should have been on the outside. Sorry. So we get approximate answers, right? We probably know the square of 2 is close to, or the square root of 2. It's approximately 1.4. Yeah, it's right about 1.4. So play with 125. So this comes out to be approximately plus or minus like 1.4. Close. Try 125, 126. Start just playing with those, trying to figure it out. We're solving for x. So they tell you x squared plus 1 equals 0 cannot be solved. Why?
He doesn't square root. You need the square root of a negative number.
Okay, B, speak more simply.
You can't multiply two numbers together and get a negative unless they're imaginary.
Well, so we can't multiply two real numbers together and then add 1, especially you get 0. Like, that's not possible. Because 0 is a real number. Right? So 0 times 0 could square and make 0, but I have this plus 1. So no matter what my result is, I have to bump up by 1. I can't get 0 out of that. So this is impossible. In the early 1500s, Italian mathematician Bombelli, these guys have sweet names. If you ever get a chance to read a math history book, do it. They have sweet names, and they did cool stuff. Raphael Bombelli invented, and I kind of hate him for this, the term imaginary numbers. Because he said, well, you maybe can't grasp it. Like, you can't think about it physically, but if you imagine, you can perceive it in your mind. You can't perceive it physically.
Is this where the abstract thought comes into being good at math?
Yeah,
Basically,
I mean, a little bit. Of like, okay, this problem can't be solved with the math we know right now. It's like if you watch The Big Bang Theory and they talk about like, the physics and different things, like, well, in this branch of physics versus that branch of physics, like, depends which one are you, like, which rules are you accepting? So Bombelli essentially said, so if I break the rules of signed numbers and their multiplication, that no number times itself could be a negative. If we forget that rule, now I've invented this imaginary numbers, which we now would like to call complex. We're trying to fix that. So what he said was, if I invent a number or a number system, then I get to solve this, right? If I change the rules, I can win the game. So he said, all right, you tell me I can't square root -1. Well, screw you. It's on. That's what Bombelli said. He's like, I'm going to invent new math. Here you go. Now, in Bombelli's world, we have this imaginary number, right? So then they said, well, really, we can grasp it more easily if we say that I squared is equal to -1. So now we just have this kind of like conversion factor, right? If I want to convert into Bombelli's number system, I can just change a -1 to I squared. Okay. So then we went back to this equation, x squared plus 1 equals 0. We said, okay, so now I can solve this. And we started playing with other functions. So since you already have an intro and you guys already know a little bit about imaginary numbers, play with a through d here. You can reference this example point. Well, okay, so I should probably talk through this. So I'm guessing there's at least a couple of us who have less of a background knowledge on this. So if you want to start working A through D, do it. You can ignore me. Otherwise, I'm going to break this down. We're always looking to factor values under the perfect square to make life easier. Here they factor it so that we have can be square rooted in the world we live in right now, can be square rooted in Bombelli's world, right, in the math that he invented. So then we break this up, and this is the step they don't show that I want to make sure we're comfortable with. Square root of a product is the same as the product of the square roots.
So you just rewrite that as 4 next.
So I have people not all, I'm saying this again because people get screwed up on this every year. The square root of a product can be broken in a way into the product of the square roots. This is extremely convenient because then we can say, okay, the square root of 16 is 4. The square root of -1 can't be done. Oh, wait, Bombelli told us it's I. And we get 4. And that is our answer. According to certain mathematicians, that answer doesn't exist. With Bombelli's number system that he allowed us to use, I don't like calling it imaginary. But we've now renamed it like complex numbers. Although complex fractions is already a thing, so that I have some discrepancies there. Or Bombelli. People will sometimes reference the I at the end of his name, like. But, yeah. All right, try A through D. Oh, okay, so I skipped a step here too. You don't really have to pay attention to this. But they formally wrote out then that -1 gets replaced with I squared. And from there, when you square root something that's squared, it just turns into itself. Ah, meant to capture, did not capture. Take 3 or 4 minutes. We'll review all these before we get out of here. You guys, we caught up with where I wanted to be.
I understand what we're doing, I just don't really understand as much why.
To be able to solve situations that previously were said to be unsolvable. That's right now, all you need to understand is that we're just practicing a solution technique. The application of it will come later. Because if we just hit you with the application, it would just be overwhelming. If I need to get you a pen that doesn't click, I can do that. But you are driving me up the wall, dude. You gotta find a quieter, clickable pen. There are legitimately pens made that click quietly. Like, it's on purpose.
I want one.
Well, okay, think about before we had fidget things, and people could, like, they wanted something to do. Give me a pen that clicks quieter. Or I just always used to do this.
Yeah, that's what I might say.
How do I break -4?
2i. 4 and
Wait.
I.
4 and I.
Wait, are we calling
Well, first,
2i?
4 and -1. Then, though, be
4 and
careful,
I squared.
because it's 4 and I squared,
Which is 2i.
which now some people like to think of it like this, as opposed to breaking up the product and showing it as 2 different things. Some people like to say, well, I can just bring this out by taking the square root of it. You get out of the square root by calculating square root. So we get 2. When I square root I, get out.
So we call it just breaking square root now?
Not really breaking, but when you separate the value into factors, you kind of think of it as breaking the number into its pieces.
I was thinking breaking because you're using I.
Mm. Mm-hmm. So now what if we're given I values?
You multiply it
Part of our
6 times squared and then it's -6. That's not 6 times -1 because that's squared -1. Seems logic. It works.
Did you say sans logic?
No, I said see its logic.
Oh. They said like sans like without, like sans logic. If we forget about logic, it's fine. That number's imaginary.
Is MathCon still a thing?
Yeah. We've been
Yeah,
meeting on
yesterday.
Wednesdays.
What is today? I'm not here. Great.
Well, when do you want us to meet?
Mondays.
Jenny, you're never here anymore.
I am.
You
I'm
told
here
me I
on
couldn't meet on Mondays.
I'm
Is
here
there
on
something
Mondays
going
and
on?
Thursdays. I can't meet on. I'm gone on Tuesdays and Wednesdays for tennis and Tuesdays.
Well, that's why I've been doing it on Wednesdays.
She's here on Monday.
Somebody else couldn't do it on Mondays.
She's on
Wait, are you the
Thursdays,
country come on
Fridays.
Wednesday?
Both. We're split.
I can come on Wednesday.
So that we can make sure we get out of here on time. -5 times 2I squared. We'll pick this conversation back up because I would like you on the team. I would like all of you on the team, but that can't happen.
I wouldn't be on the team.
The answer is
I
20.
said
she said.
negative. Well, yeah.
When you square 2I, what do you get?
You get
Or I
squared.
squared.
-4I squared, I squared. Colin, what are you thinking?
Well, the end total for 2i squared, or 2i squared is -4, or square root -4. Actually, no.
It's -4. It's 20. It's
It's
just
-4.
It's just -4.
Oh, right.
It's 20.
So this
20.
becomes. My smart board's broken. Something's wrong with it. -5 times -4. And we get 20. Yeah, there's no reason that, well, not no, but very little reason why we would need to do this. It's just practicing, do we understand how squaring and square rooting with the negative or with the I works. So if we then have, to wrap it all up, square root of -25 we would rewrite this as square root of
25 times I squared.
negative, well, if you wanted to, we could show -1. Then we could show that that is actually I squared. Like if on a test it was asking you like write a proof of solving -25, you might go ahead and formally write out the -1. Then replace it with the I squared. Then we could separate our square roots if we wanted. And get 5. Questions, comments, concerns? Please return your graphing calculators up to
What if I told you
because of the 7. I can't remember to put them away.
Yeah.
If you want the honest answer. Oh, I have papers to give you.